Hi everyone, I hope you are fine and welcome to another video of Mastercam. So we have started the module number 5, which is on about the multi-axis toolpaths, and we have covered the introduction to multi-axis, and we have covered the 3+1 and 3+2 both meet positioning. And in the previous video, we have discussed about the swap and swap milling operation. So today we are going to perform the automatic roughing using 3+2 axis, which is a very interesting topic and very interesting toolpath positioning system, toolpath system. So let's get started. So here we have already created a geometry, and what you see over here, we have a square box. And on the square box, on the top side, we have a pocket. On the other sides, we have a round pocket and the ellipse pocket and the round pocket here and the rectangular pocket here. So all 6 sides, on all 5 sides, we have some operations to perform. And on the bottom side, we have a stock fixture setup, which will be hold on the chuck of the C-axis. So definitely, first thing we need to do 3-axis milling, and then on the other side, we're going to use the other 2 axes. Okay, so definitely it's called the 3+2. But the most interesting thing is that it will automatically perform the 3+2 machining operation on this block. Okay, so how it's done, let's get to. So go to Toolpaths, and we have to define the stock first. So we have a stock. I just write the name stock. Click on the solids. So just need from 50. This upper box is 50 millimeter and the lower box is 40 millimeter. So it's total 90 millimeter. So let's define the upper area, which is upper box, which is 50 millimeter in thickness. Okay, so we have this stock. Now what we need is go to Toolpaths and select the automatic roughing. So where we can find it, this is 3+2 automatic roughing operation. So just click on this, and you need to select the appropriate tool for this operation. So everything what you see over here, we just need a single tool to perform all these operations. Before, it doesn't need any bar nose or any complex type tools. So we just need to select a simple single tool for this operation. So I just start from the single tool and simple geometries, so that you can easily understand what we are going to perform in multi-axis toolbox. So go to select library tool, and you have to select appropriate tool. So go to filters and filter your desired result. So I'm going to select the end mill. So here I'm going to use the 10 millimeter end mill. Set the spindle speed to 15,000. Feet rate is 1500 millimeter. 1000. That's like it here. So go to Toolpaths. Say we have already select the 3+2 automatic roughing. Go to model geometry, and we have to select the model which you need to machine. So I just need to perform this machining. Okay. So go to select entities, just select your model, solid, this like this. Or you can either select all and poly. Okay. So how about the avoidance geometry? So I just don't want to remove that material. So just what I'm going to do is I'm going to set the avoidance geometry, clean the surfaces, this surface, this surface, this surface, this surface, all of this surface. Okay. So because this this block is going to be hold down in the jets, and therefore this node need to machine that something. So okay, change method. We have selected geometry, which is going to be machined. We have already set the tool folder, which is by default setting. Go to stock. So we have the stock model. We have set the stock. So what we have is this stock. Okay. So if you have a geometry, then you have to set this user-defined geometry. So we have already stock. Go to cutting parameters, which is the most important part, and here shows that the pattern of how the cutting will perform is dynamic, or the offset, or we need to parallel. So you need to select an appropriate. So definitely it's all about the offset, because it's definitely follows the geometry, and it's what we say that it's offset geometric group. Set the depth of cut, which is 5 millimeter, or you can set the depth of cut according to your cutting tool parameters, or cutting tool requirements, or the material type we're using. So let me give this roughly to 1 millimeter. And how much slices you want? You want to cut material in 5 steps, you want to cut material in 20 steps. Here is given and find the slices to cut that material. Okay, so I just select the constant depth of cut, which is 1 line. About the area, so my area doesn't contain any undercuts, so it's just on the face. So there is no undercut, there is no rest roughing. So if you want to perform the rest operation, you just give the rest rough, and it will definitely give remove stock according to the rest rough you have set it. So just don't need to set the rest rough. This select the containment if you want to set your tool in an organized area. So you have to select the containment. So that doesn't need to set any containment. I just want to machine all these blocks in all these sizes. So how about the closed offset? If you want to set the closed offset, no, just don't need to set the closed offset. We have the cut tolerance of 0.1 millimeter. So according to the surface. So that's enough. Okay. How about the cutting method? If you want to perform in a zigzag, in a spiral, in one way, let's select this zigzag way. And how about the direction of cut? It's applying minimal convention. Let's just select the command. How about the step over distance, which is 1 millimeter? We have a cutter which is 10 millimeter in dia. So maximum step over is 1 millimeter. So we'll set it 5 millimeter. It means that 50% of our cutter will be applied. So next thing is the advanced options here. And we'll set this by default. Go to depth of depth step. Okay, so here is the option. If you want to set the depth of cuts, first depth of cut or final depth of cut, you can select this depth of cuts. But we have the constant depth of cut set it here, which is 1 millimeter. We can either select or give the values for each depth of cut here in this depth step. How about this heights? It's default according to stock and machining geometry. The most important thing is the tool axis control. So as you know that it's a 3+2 automatic roughing toolpath, and in this toolpath we are going to perform both 3-axis equation and the extra other 2 axes, whether it should be the C axis or A axis or B axis. Okay, so the mod method is automatic. If you select the manual, then it should be defined by this method. Okay, so first thing is the Z axis is 1, Y0 and X0. It means that it should be perform the operation according to the geometry you have set, which is this, and or according to your plane you have selected. So go to plane, select and see that which plane I have already selected. So this is in upward direction. So definitely this part is going to be machine first. So you can set manually by selected tool positions according to from the top side. If you want to select the front side, this would be the front side. It will automatically select this selection. If you want more like sides, this side, or if you want to set the solid face, for example, I just want to remove that side. Okay, so it will be set this side. Okay. Or if you want to set it automatically, it will automatically study your geometry and set the planes according it and make the toolpath according that geometry and plane. Okay. So how about so let me first show you the mode of automatic method. Okay. So go to Gluon, okay, go to linking, okay, feed rate, all these settings, just set as default, go to and just click on okay to define the settings. So it's just calculating the toolpaths. So just need to wait for that. So it's calculating your toolpath. So what you see over here, it just create the first step is this toolpath, then this sides and this sides, front side, sides, left, right, top, front and back side, all the machine pen. So all these 3 axes, then the sideway 3 axes, and this way, this way, this way. So it automatically set the planes and the geometries. Let me show you how it actually works. So it's processing the NC data. So this is how it performs the operation. Okay. So just selected this first. This side. But then it will move on this side, which is the top side. So this is a very interesting toolpath. It automatically defines the plane and defines where it should have to cut the material according to geometry. So it study all the geometry first and then create the planes and then set the origins accordingly. And now on this side. So this is how the 3+2 roughing operation is done. Let's go to close this and let me show you how you can define manually. Go to parameters and go to tool axis control, set it semi-automatic, and you can remove all these things. So what I'm going to do is I'm going to select this by tools plane. Okay. So this is what we have the top side. So just select the top. It automatically select the top. We have already the top. So just remove it. Go to select toolpath. Go to front. It goes front side. Then go to and select the solid face. And this face, okay. Go and the other face. This face, okay. And one more thing on the other side, this side. And this, okay. Click OK. Refresh. So just calculating the toolpath and it will perform it semi-automatically. So you just need to select your desired faces which you want to machine then. So this is how the 3+2 roughing operation is done. So it will take some time. So here we go. So this is how it works. Let's go to backplot and here we go. So this time it's select from the top side.
Carefully.
And so this is how the machining operation is done. Go to machine and select the select run. So let's see how it actually works. So this is how the machining is done on a real time. The workpiece hold down on the C or rotary axis. This is Z, this is X in Y direction. So all these are 3-axis machining and the other axis is this rotating. So this is how it works. So hopefully you understand how the 3+2 roughing operation is done. So stay tuned for more videos. Thank you very much.